Here we are verifying Ohm's law in the laboratory, the virtual one. So things that is required is a resistor, an ammeter, a voltmeter, a plug key and a battery eliminator to verify Ohm's law. So starting with the battery eliminator, we have set the battery eliminator. So we are connecting its terminals to the devices. So connecting it to the plug key, and then the plug key's other end we are connecting to the ammeter. Ammeter is always connected in series in the circuit. So ammeter's one end is connected to the resistor, whose resistance we will find in the process of verification of Ohm's law. A voltmeter is always connected in parallel to the resistor. So parallel means end to end. So voltmeter's two terminals are connected to the resistor's two terminal, and the battery eliminator in turn is connected to the resistor. So here we have a resistor, parallel to it there is a voltmeter, in series there is an ammeter, and there is a battery eliminator that will be the power source for us, and a plug key. This is the circuit connection for verification of Ohm's law. To begin with, we should know what is the range of ammeter. So range of ammeter is from 0 up to what you see in the ammeter. So here maximum number is a 3. So the range of ammeter is, I'm just inputting here so that you understand it well. So 0 to 3 amps. And between 0 and 3, how many divisions are there? If we come to know, then we will know the least count of the ammeter. So the least count of ammeter is 0 to 3. The total has how many divisions? Just I'm counting it. So 1, 2, so there's a 10, 20, 30. So 3 is the maximum number divided in 30 divisions. So 3 over 30 is 0.1. So 0.1 is the least count of the ammeter. That means every one division is 0.1 ampere. So while doing the experiment, we will be reading the number of divisions, and to the number of divisions we will multiply least count to know the ammeter reading, that is amount of current in the circuit. So the given ammeter has a positive 0 error. Actually there is no error in this. It's a good one, actually good ammeter. We are verifying Ohm's law. Verification of Ohm's law would mean that okay, so that was a message that popped in. So as we increase voltage, the current also increases or not. That's verification. Now here the voltmeter ranges from 0 up to 10. So the last number is 10, and least count would be from 0 to 10, how many divisions are there? So 10 divided by total number of divisions that you see on this voltmeter. So total number of divisions is at 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So 10 number is divided by 100. So 10 divided by 100. So here least count is also 0.1. So voltmeter and ammeter has a common least count. Now when we read the voltmeter reading and ammeter reading, we have to just see the number of divisions. To that we will multiply least count and we'll know voltmeter and ammeter reading. Now let's switch on the battery eliminator to start. So it is a 0 volt right now. So for a 0 volt we can't perform the experiment. So let us first take a voltage supply of 1.5 volt. Now let's see how much the voltmeter and ammeter is going to read, because there is conductor. So conductors offer some amount of resistance, and there is a resistor also in the circuit. So let's read how much the ammeter reads. So ammeter is reading 7 divisions. 7 divisions. So 1, 2, 3, 4, 5, 6, 7. 7 divisions into 0.1 will be the ammeter reading, and the voltmeter is reading the 14 divisions. 14 into 0.1 is a 1.4. So the voltmeter reading is 1.4, ammeter reading is 0.7. Since here voltage by current, that is how we calculate resistance. So it is at 2 ohms. Now let's do the experiment for some other voltage source. Now let's set it for 3 volts. Battery eliminator is for 3 volts. Now as we close the circuit, so keep this in mind, this is how you are going to perform Ohm's law activity in the laboratory. So now how much current is there? Read the divisions from 0. So from 0 I am reading, so that is 14 divisions. So 14 into least count, 14 into least count, that is 1.4 is the amount of current, and on the voltmeter there is 29 divisions. Least count is 0.1, so 2.9 should be the voltmeter reading. Then voltmeter reading by ammeter reading, V by I is the resistance. So when we divide, we will get the corresponding resistance of the resistor. Now let's take the battery eliminator for 4.5. So this is the third reading we are taking. While doing any experiment, minimum 3 readings will be enough to verify an experiment or a law. Now the reading is 21 divisions into 0.1. So 2.1 will be the ammeter reading, and voltmeter reading is 43 into 0.1. So 4.3 it should be. So you see 4.3 is voltmeter reading, ammeter reading is 2.1. Now before I calculate the resistance, observe this table. This by 3 readings we can verify Ohm's law. So now you see, as voltage is increased from 1.4 to 2.9 to 4.3, the magnitude of current in the circuit and across the resistor that we have taken in the circuit also increased from 0.7 to 1.4 to 2.1. One more, from the battery eliminator supply, first we have given 1.4, the voltmeter read 1.5 volt we have given taken from the battery eliminator, but the voltmeter read 1.4. So that through the conductors connecting wires, some amount of resistance is being offered. As a result, the voltmeter read 0.1 less than the real supply. So that is one point. And here from the table we clearly understand that as voltage increased, current also increased. So voltmeter reading is directly proportional to the ammeter reading. Voltage is directly proportional to the current supply, and hence Ohm's law is verified. Voltage by current will always be a constant, and that constant is called the resistance of the resistor. Here resistance is in the first reading 2 ohms, second is 2.07 ohms, and now it is going to be approximately 2. So now we can take few more readings by increasing the battery eliminator reading, and hence we can verify Ohm's law through this circuit diagram. So voltage supplied or potential difference across the ends of a resistor is directly proportional to the magnitude of current thus produced. So at constant temperature, voltage is directly proportional to current, and hence Ohm's law is verified.